Okay, let's learn how we can find the greatest common factor or divisor of an infinite group of numbers. So let's go down here. What's our strategy? First, we should find the smallest number out of all of the arguments. How can we do that? Let's do let smallest equal to math.min, passing in our nums argument. Okay. The second thing is that for the way that I'm doing this, we need to get rid of all the zeros in here. So if they have a zero, we should remove it. Because when you try to find greatest common factor, having another zero does not matter because zero is divisible by every other number. Okay? So that's why we don't need it. So we can do something like, let me put this on top, nums is equal to nums.filter, and we're filtering out all the values that are not equal to zero. Okay, so now what can we do? Now I'm gonna do, actually let me put this in a function. So const all are not divisible, and we'll see why, which is an arrow function. And what is this arrow function returning? Well, it's returning nums.sum. Okay, so I'm going to take our arguments array and I'm going to check, hey, is at least one of the numbers inside passing this condition? So the condition is going to be, we're going to check to see if, hey, if I take every value in that array and I try to divide by the smallest number, am I going to get any remainders? And if any of these are not divisible by that number, I will get a remainder, okay? And sum will return true. So down here, I can do while all of these numbers are not divisible. What are we going to do? Well, all we have to do is actually decrease the smallest number by 1 each time. And then after this while loop finishes running, we know that we're either done or the greatest common factor is just 1. Okay, so I can do greatest common factor is, and then smallest, like this. See, so right now we have 10. Now, if I take out the filter that takes out the 0, if I comment this out, you're going to see that it's -1, right? Because since we have 0, right here, it's going to try to do 0 divided by 0, and that's not going to work, okay? So let's put this back. Now it works. 10, 20, and 30 still works. 5, 15, 20, we should get 5. All right. Now, another way that we can write this check right here, let me see. So instead of checking to see if there's a remainder, we can check if, hey, if I do number dot is integer on the value divided by the smallest number, is it going to be an integer? Okay. So this logical not operator is checking to see, hey, are any of these numbers not divisible by the smallest? Okay. Or what it means is that, hey, when I divide that number by the smallest, it's not an integer. Okay. So with this, it also works. Okay. And I think this way is actually a lot better than the other way because it's more readable, to me at least. Okay, I hope that was helpful, and I'm sure there's better ways to optimize this that I haven't figured out yet.